Hi folks, this is Calc 2, Checkpoint Quiz 8. We're given some trigonometric integrals to deal with today. Here we have sine to the fourth 2x, cosine to the fifth 2x dx. And the way we handle a product of trigonometric functions sine and cosine, where the angles are the same, is we try to see if we can keep one of them back in reserve for a factor of du. So, is it possible to take this product and if I keep a cosine back, I would be thinking of this being the du. I would need then to be able to convert everything that's left over in terms of sine. So in this case, I'd have to convert everything into sine of 2x. Is that possible? Well, what's left over out here that isn't in terms of sine is an even power of cosine. I know from the Pythagorean identity that cosine squared of 2x plus sine squared of 2x is always equal to 1, which means I can convert cosine squared 2x into terms of sine squared 2x. And since I can do it for cosine squared, I can do it for any even power of cosine, including cosine to the fourth. This says that cosine to the fourth of 2x, which I can think of as cosine of 2x squared squared, is 1 minus sine squared 2x squared. So that's what I'm going to do. I'm going to rewrite this as the integral of sine to the fourth 2x times 1 minus sine squared 2x squared cosine 2x dx. And then I'll make the formal substitution. U equals sine 2x. So my du is more or less the cosine 2x dx. But I've got an extra factor of 2 that I need. Alright, so as usual, I can put the 2 in by putting a 1/2 out front. And now in the land of u, I've got 1/2 integral u to the fourth 1 minus u squared squared du. So that's 1/2 integral u to the fourth 1 minus 2u squared plus u to the fourth du, which is 1/2 times the integral u to the fourth minus 2u to the sixth plus u to the eighth du. This is a nice friendly Calc 1 polynomial, which we'll deal with using the product or the power rule. Okay, so here we go. U to the fourth, integrate that, I get u to the fifth over 5, but I've got a 1/2 there waiting to make that 1/10 u to the fifth minus, I've got a u to the sixth, that gives me u to the 7 over 7. I've got a 1/2 to cancel out that 2, so 1/7 u to the 7th, plus I get a u to the 9th over 9, so I've got a 1/2 there, that's 1/18 u to the 9th, plus c. And now back in the land of x's, I was letting u be the sine of 2x, and so I get 1/10 sine of 2x to the fifth power minus 1/7 sine of 2x to the 7th plus 1/18 sine of 2x to the 9th plus c. So that'll do it for part A. Alright, in part B, I've just dropped off the cosine fifth 2x, and I'm just left with sine of 2x to the fourth. So, is it possible to keep a sine back and convert everything into cosines? Well, if I kept the sine back, once again, I would be looking for this to be the more or less the du. So I'd be thinking of a cosine substitution. Well, the problem is I have an odd power of sines left, so I can't easily do that conversion, do the conversion using the Pythagorean identity. And since there's no cosines to be sparing at all, what I need to do is fall back and use a different technique that we talked about, namely the power reduction. So from trigonometry, we know that we can work the double angle identity for cosine to get the following. Sine squared of an angle is 1 minus cosine of twice the angle, all divided by 2. And similarly, cosine squared of an angle is 1 plus cosine of twice the angle, all over 2. And so these allow us to reduce the power on the trig functions. And so starting off with the integral at hand, this is the integral sine to the 4th 2x dx. I can write that as sine squared 2x squared dx, and I can reduce the power using the power reduction formula. 1 minus cosine of twice the angle over 2. Now, the angle I've got in there now, the argument of the sine function I have now is 2x. So the 2x is what's in there. So when I double 2x, I'm going to get 4x dx. And I'm going to multiply this out. And so in the denominator, I get 4. In the numerator, when I multiply that out, I get 1 minus 2 cosine 4x plus cosine squared 4x dx, which then I can break up. I've got the integral 1/4 dx minus 1/2 the integral cosine 4x dx plus 1/4 the integral cosine squared 4x dx. The first two integrals I can do, they're Calc 1 integrals. That's 1/4 x minus the integral of cosine 4x is going to be more or less sine 4x. I need a 1/4 to counteract that 4, so that's 1/8 sine 4x. And I need to use power reduction again to knock down this power of cosine. So that's 1/4 integral power reduction. 1 plus now cosine of twice the argument, 8x over 2 dx. So I've got 1/4 x minus 1/8 sine 4x plus, I've got a quarter there and I got a half that comes out. So I've got a 1/8 integral dx plus a 1/8 integral cosine 8x dx. So I've got 1/4 x minus 1/8 sine of 4x plus a 1/8 x from that integral. And the integral of cosine, once again, is going to be sine, and I've got to adjust for that 8. So that's 1/64 sine 8x plus c. And so I combine the like terms. I have 1/4 x plus 1/8 x. That's going to give me 3/8 x minus 1/8 sine 4x plus 1/64 sine 8x plus c, and that's my final answer. And as we've seen in class, if we try to check our answer by taking the derivative, we can do that, but we're going to have to take the derivative and basically reverse all of the trigonometric identities we did here. That'll do it for Part B.